Hello, this is going to be part two of this method. So I think I stopped off on example three. So example three says, uh, find the volume of y equals x squared minus 4x plus 5, where x equals 1, x equals 4, and y equals 0 about the x-axis. So when you're talking about the x-axis, you know you're going vertical. So you know you're going top to bottom, and we know our integrals is from a to b. So let's kind of draw what we need. X squared minus 4x plus 5, that is a let's scroll with the easier one. X equals 1. I know that. I know what that looks like. That's a vertical line. What does y x equals 4 look like? It would look like this. And then this is y equals x squared minus 4x plus 5. That's a polynomial. It's a U-shaped parabola, so it might look something like this, right? So this curve is y equals x squared minus 4x plus 5. And we got to find the volume about the x-axis. So here's the x-axis. So that means you're standing here, and our head is the top and our feet is the bottom. So we're going to use this volume. That's pi from integrals a to b from top minus bottom squared dx. So what's our integrals? I believe it's because it's in terms, everything's in terms of x. Uh, our x is 1 to 4. So we're going to use our a is going to be 1 and our b is going to be 4. And then if you were going across the x-axis, we're going vertical. So our top is the polynomial. Minus the bottom, which is I believe, y equals 0. So, and then we have to put a dx because it's in volume around the x-axis. Everything's in terms of x, right? And we got to square this. So it really is volume equals pi from the integrals 1 to 4 of x squared minus 4x plus 5 square dx. So we kind of, before we take the integration, I don't think we could do use substitution. I think what we have to do is FOIL this out. And clean it up, right? And collect like terms. So when I do FOIL this out, the volume is going to be pi from 1 to 4. And I believe we're going to get, this is what, when I do the work, you should get x to the 4th minus 8x cubed plus 26x squared minus 40x plus 25 of d of x. Okay, and we can take the volume of that. Oops. Yeah, we could just take the integral. So it's pi. And then we know that the integral of 1 of x fourth is 1/5 x5. The integral of negative x cubed is negative x4 over 4. Plus the integral of 26x squared is 26x cubed over 3. The integral of negative 40x is negative 40x squared over 2. And the integral 25 is 25x. And we are going from the boundaries 1 to 4. The volume is pi. And I guess we can kind of clean this up. 1/5 x5 is really x5 over 5 minus negative 8x4 over 4. That's simplified as negative 2 x4. 26 over 3 is just 26, so I'll just leave it as it is. Negative 40 over 20, negative 40 over 2 is negative 20 x squared. 25x, that's just 25x. And then we're from 1 to 4. Okay. And then all you got to do is apply the upper minus the lower, right? So it's going to be 4 fifths 5 minus 2 times 4 to the 4th. And then apply the lower boundary. So this is going to be uh, and when you put it all together, you get volume equals 78 pi over 5. Okay, you can do all the work, you put that in the calculator, and then distribute the pi, you should get volume of 78 pi over 5. Okay, so that was example 3. Let's move on to example 4. So example 4 says, find the volume of the solid form by revolving the bounded region about the x-axis of rotation. And we are given y equals 9 minus x squared, bounded by the x-axis, so you're going vertical, and y-axis in the first quadrant about the y-axis. Okay. Okay, so let's draw our image. How do y minus 9x squared look like? That's like a, I don't know, that's a U-shaped parabola. And we can only use, so it would look like this. And then the topmost y value is 9, right? It would look something like this. And then we're in quadrant 1, so we can use this. So this is what we care about the most, the shaded region. So we're making a slice horizontal because it says uh, about the y-axis, right? So this one is different now. It says here's the y-axis. Now we're used to doing the x-axis, but we're evolving around the y-axis. So that means we're going like this. We're standing here. You are right here. You are standing horizontal. So we're making a horizontal slice. So if that's true, that means we're going to use the formula v equals pi from this time we're going from c to d of r squared of dy, right? where we are revolving around about the y-axis, everything has to be in terms of y. And then this time, I still think it's still the top minus bottom. So you're standing here, right? We're going horizontal. So yeah, that's very important. So how to do the top and bottom. So it's still top minus bottom dy. So what would be our top? I think our head would be the top, and then our feet would be the bottom. So the head is touching the the square root graph, and then our feet is touching the I think it's y equals 0. But be warned, this curve here, it's y equals 9 minus x squared, right? But if we're doing it horizontally, that means everything has to be in terms of y, right? So we kind of have to solve this right here. We're going to have to solve it for x. So solve for x, we want it in terms of y. So I would have to like subtract 9. And then divide this by -1, or everything by -1. You get negative y plus 9 equals x squared. And then take the square root of both sides. So I get x equals plus or minus square root of 9 minus x squared. Okay, so our volume is going to be from pi. And what do you think our boundary is going to be? This time we're revolving around the y-axis, so that means it has to be in terms of c and d or from y's. So this would be 0 and this would be 9. So I think our c is 0 and our d is 9. And then we're still doing revolving around horizontal, so our head is touching the square root graph, but we convert it into a wait. This should be why did it? This should be a y. Sorry, because we have to convert it in terms of y. So this is net. This square root graph was originally y minus 9x squared, but because we have to put it in terms of y, we solve for x. Now it can be also be expressed as square root of 9 minus y squared, right? And then it's minus 0 squared dy. Okay. Uh, this is just this 9 that's just square root of 9 minus y squared. And then when you square that, that's just 9 minus y squared. Wait, there's no square here, right? Yeah, it's just 9 minus y. Okay, and then we can easily take the integration of 9 minus y. The integration of 9 is 9y. The integration of negative y is negative 1/2 y squared. And we are going from the boundaries 0 to 9. Okay, so let's do our upper and minus lower. So it's going to be 9 times 9 minus 1/2 9 squared minus bracket, and then place your y with 0. I know this is all going to be 0. And then don't forget you're still multiplying everything by pi. So it's going to be pi, and then this is going to be 81 minus 9 squared is 81, 2. And when you put it all together, simplify, you get 81 pi over 2. So if you kind of see the bigger picture, it's kind of like a bowl actually, right? In 2D, it would look like this. And then if we're revolving it around the y-axis, we're going to make tiny disc like this. From 0 to 9. So that's the bigger picture. Okay, let's move on to example 5. Okay, so example 5, we have x equals 1 over square root of y, and our boundary is from our y boundary is from 1 to 4, revolving around the y-axis. So because this is good, we have it in terms of 1 to 4, so we already know our C and D, which is 1 and 4. So 1 is our C and 4 is our D. And in terms of y, this is already in terms of y, so we're really good. So it's going to be, we're going to use volume equals pi from C to D. And we're still doing top minus bottom squared dy. So if you want to draw your image, it should look something like this. How does this look like? X equals 1 over square root of y. It would look something like this. So we're going from 1 to 4. Here's 1, here's 4. It would look something like this. Right? And then here's your head. This would be your top because we're going revolving around the y-axis. So it's still top minus bottom. So the top is now your head, and then your bottom is your feet. It's going to be volume equals pi. And then our lower boundary is 1, and our upper boundary is 4. And our top is this, which is already in terms of y, so we don't have to convert it. Usually we have to. Minus the bottom, I think this is a vertical line of x equals 0, so it's going to be 0 square dy. So this is really square this. This is going to be 1 over square root of y squares y. And it's going to be volume equals pi from 1 to 4 dy. So what's the integration of 1 over y? It's easy. It's ln of y, ln of absolute value y. So, and then we plug in our boundaries from 1 to 4. And don't forget, we still factor out as y. So it's going to be ln of absolute value 4 minus ln of absolute value 1. And we are multiplying by pi. So your final volume is going to be pi ln of 4 because ln of 1 is 0. Okay, there's your final answer. So if you want to look at the bigger picture would look something like this. it would look something like this. Looks like some kind of hat, and then if we're revolving it around the y-axis, making tiny discs like this. There you go. So that would be the bigger picture. Okay, let's move on to example 6. We have y equals 2 minus x squared, y equals 1, and about y equals 1. So we have y equals 2 minus x squared, y equals 1, and we got to revolve it about y equals 1, and then they give us this other parabola. So we got to start drawing our graphs. So 2 minus x squared is a parabola, upside down parabola. I believe it has a y-intercept at 2. It would look something like this. And then revolving it around y equals 1, here's 1. It would look something like this. If you want, you can also rewrite this 2 minus x squared. You can rewrite this as negative x squared plus 2, if that makes it better. I think this is the area. This is the region we need. This is the volume we need. This shaded area. Oops. So what we need is, yeah, so now what we're doing is if you look at the bigger picture, it's going to look like this. And I think we're standing up right like this. So the top is your head, which is the parabola, and then the bottom is the vertical line. I mean, horizontal line. And it forms a disc. So I think we're going to use b equals pi from the integrals a to b, and then top minus bottom squared dx. Oops. I lost it. Okay, so now we got to find our a to b. We don't know that, right? We got to find these point of intersection. We know that this line is y equals 1. And we know that this line is y equals negative x squared plus 2. And if we're doing it in terms of x, what we're going to do is set the equation to each other. So we'll say 2 minus x squared equals to 1. and then go in and solve for x. So I'm going to subtract 2. 1 minus 2 is -1. X squared equals 1. And then the square root of 1 is 1 and -1. So I think that's our A and B. Our lower boundary is -1 and our upper boundary is 1. And then, so if you look at this image, our top is the parabola, and our bottom is that horizontal line. And then square this whole thing. So we got to do some algebra before we take the integral. Let's clean this up before we square this. So what's 2 minus x squared minus 1, and then square that? So 2 minus 1 is 1, right? 2 minus 1 is 1. Then you have a negative x squared, and then you square that. And when you FOIL that out, you should get 1 minus 2x squared plus x4. So that's what we're going to take the integral. We can now take the integral. So what is the integral of 1? It's 1x. What's the integral of negative 2x cubed? That is negative 2x cubed over 3. What's the integral of x to the fourth? That is 1/5 x5. And we got to do our boundaries from -1 to +1. And then we do the upper minus the lower. So it's going to be 1 times 1 minus 2 times 1 cubed over 3 plus 1/5 times 1 to the 5th minus bracket 1 times -1. And then we still, remember, we still have to we factor out a pi. So when you do all the algebra, I'm going to save us time. You could do this on your own time, but you should get a volume of 16 pi over 15. So if you want to look at the bigger picture, it would look something like this. And then you're going to make a disk like this. Okay. So let's move on to example 7. So example 7, we have y equals x squared, y equals 4, and we have to revolve it around y equals 4. So let's just draw our image. This is easy. This is a parabola. This is also a horizontal line. So it should look something like this. Okay, y equals 4 would look like this. It's a horizontal line like this. And then y equals x squared, that is a parabola. It has a y-intercept of 0, 0, and it's open upwards like this. Okay, so this is the region we need to worry about, this shaded region right here. So what we need is this point of intersection here, and then this point of intersection, because we need our boundaries, right? So I think we're going to use pi, and then I think we're going to use boundaries from A to B. If we're revolving it around y equals 4, right? Uh, yeah, we're going to use this, and then it's still top minus bottom square dx. So our top, so I think this is how we, if we're standing up like this, our head is touching the top, which is the horizontal line. And then our bottom is, our feet is touching the bottom, which is the parabola, right? So it's going to be volume equals pi. And then we're going from -2 to 2. And then our top is 4. And then our bottom is the parabola square dx. Uh, let's FOIL this out before we take the integral. So what's 4 minus x squared? That is going to be 16 minus x squared plus x to the 4th. So that's going to be 16 minus 8x squared plus x to the 4th of d of x. So yeah, we're revolving around, since we're revolving around y equals 4, since we're revolving around y equals 4, everything has to be in terms of x. So wait, how did I get -2 to 2? I think I just did this one step ahead of me. So how did we found -2, our lower boundary -2, our a value -2, and our b 2? What I did was we found the point of intersection. So basically I said x4 equals to 4. And then I took the square root, and then square root of 4 is +2 and -2. Okay. Okay, now we can start taking the integration of each term. So the integral of 16 is 16x. The integral of -8x squared is -8x cubed over 3. The integral of x4 is 1/5 x5. And then our boundary is from -2 to +2. So that is going to be volume equals pi. Well, that's 16 times 2 minus 8 times 2 cubed over 3 plus 1/5, 2 to the 5th minus bracket, and then replace your x with -2. So I get this is going to be 32 minus 64 over 3 plus 32 over 5 minus, this is going to be negative 32 plus 64 over 3 minus 32 over 5. So when you put it all together, your volume should be 5/112 pi over 15. Okay, let's move on to example 8. Okay, so example 8 says find the volume of the solid formed by revolving the bounded region about the axis of rotation. We have y equals x, y equals 0, y equals 4, x equals 6, and we have to revolve it around x equals 6. So let's start drawing our image. So these aren't too bad. Y equals x is a linear line, y equals 0 is a horizontal, y equals 4 is a horizontal, x is a vertical line. So it should look like this. Y equals x. Let's see, y equals 4 is 1, 2, 3, 4. It would look something like this. And x equals 6. I think it would look something like this. It's a vertical line, right? Here's, let's pretend x is here, 6. And yeah, we just found our, so this shaded region is our, what we want to find the volume of. And we got to make tiny disk. Let's find our point of intersection. Okay, so I know this point here is 0, 0. This point here is 6, comma 0, right? Because this horizontal line is 6 and the y value will always be 0. And then what do you think this point is? Well, this vertical line is 6, and then this upper line, this upper y value is 4. So what we're really doing is, you're going to draw a better image. It should look something like this. It would be revolved about, it says we're revolving around the x equals 6. So here's 6, and we're going to go like this. We're revolving x equals 6. So what we're really doing is we're standing horizontal like this, because we're trying to revolve it around x equals 6, right? And yeah, and so the top, yeah, this is, our head is the top, and then our legs is the bottom. So this line is y equals 4. This line here is x equals 6. This line here is y equals 0. This line here is x equals y. So we're going to do the disk. So it's going to be volume equals pi from the interval c to d. And we're going to do top minus bottom squared dy. And our top is 6 and our bottom is 0, right? No, our top is 4. Why did I say 6? And our bottom is 0. So our C is 0, and then our top D is 4. And then our top is the horizontal line. I mean, the vertical line, x equals 6. And then our feet is touching this curved line, which is the linear line, which is y, dy. And then let's square this before we take the integration. So this is going to be, let's see, 36 minus 12y plus y squared. So our volume is going to be I from 0 to 4. And then this is going to be 36 minus 12y plus y squared dy. So the integral of 36 is 36y. The integral of negative 12y is negative 12y squared over 2. The integral of y squared is y cubed over 3. And then we're going from 0 to 4, and then don't forget we took out a pi. So yeah, so the volume is going to be pi 36 minus 12 on this bracket, and then I know this is all going to be 0. So when you put it all together, your volume should be equal to 208 pi over 3. Okay, let's do 2 more examples, and then we'll end it here. Okay, example 9 says find the volume of the solid form by revolving the bounded region about the axis of rotation. So we have y equals e to the negative x, y equals 1, y equals e, which is a constant, x equals negative 1, and we have to revolve it about the line x equals negative 1. Okay, so we know how this graph looks like. This is a typical, what is this called? Oh my gosh, I forgot. It's not a log graph, it's the opposite of log, exponential. And it's decreasing exponential, right? Because of this negative x, it's sort of like a reflection. So let's kind of draw it out. Y equals E is a horizontal line. It's like E is about 2.7, so let's pretend this is E. And then y equals 1, here's 1. And then this graph here would look something like this. Oh, oh, and then where's negative 1? Negative 1 is right here. Okay, so this is the area that we care about. And if we're going to revolve it about x equals -1, here, let me draw a better image. So it should look like this. Let's call this C, and then let's call this D, or the E line, call it D. Okay. So now we're heading it, our body's going to look like this. So your head, this is the top, and then this is x equals -1 is now the bottom. So we're going to do the disk from C to D, from top minus bottom square dy. And then our C is, what is our C? Is 1. And our D is E. And then our top is the negative ln of y. Well, thing is, we have y equals e to the negative x, and we got to solve for x. So how do we solve for x? Well, we have an e, so there's a good chance we're going to take the ln of both sides. So this is going to be ln of y equals ln e cancels, you're left with negative x. And go ahead and solve for x, so you're going to divide this by -1. So x equals negative ln y. So it's going to be 1 minus ln of y squared dy. And you got to use the calculator to take the integral. So yeah, FOIL this out, 1 minus ln of y, and then use the calculator to do your upper and lower boundary. So when you put it all together, you should get volume equals pi 2e to the -5, which is about negative, that's about 0.437. So FOIL this out, and then plug in your upper minus your lower. Then you have to use a calculator, and you should get this. Okay, I lied. This is the last problem for this section, so we will stop here. Okay, thank you. Bye-bye.